Let's continue to discuss this chapter on options. First, let me review what we have talked about in the last lecture. There are two kinds of basic options. The first is a call, the second is a put. What is a call? It basically gives the holder the right to buy an asset at the exercise price on or before the expiration date. What is a put option? Well, a put option gives you the right to sell, right? So basically, it gives you the right to sell an asset for a specified exercise price on or before the expiration date. And then a related concept about call option and put option is in the money, out of the money, and at the money. So the first one is ITM, right? Oh, let me change the color. So the first one is ITM, in the money. What is a in the money option? Well, if you exercise the option right away, then if you could have a positive cash flow, then this option is called in the money. For example, if you're having a call, then if the market price is larger than the exercise price, if you exercise it, then you will buy the asset at the exercise price. So your profit would be market price minus exercise price. So you will get a positive profit. In this case, this call is called in the money. What about a put? Well, for a put, if the exercise price is larger than the market price, well, a put basically means you will sell your asset at the exercise price. So if you can sell at the exercise price, and if the exercise price is larger than the market price, then your profit is given by exercise price minus market price. So in this case, we say this put option is in the money. And then the opposite side is out of the money, right? So it's OTM. Of course, if a call, if exercise price smaller than market price implies this call is in the money, then exercise price larger than the market price implies this call is out of the money. And then we have the third special case, which is at the money. So basically, when exercise price equals asset price, then this call is at the money. I know these definitions are sort of like redundancies, right? But in both academic research and in both actual investment industries, people do use these terminologies, right? They do use in the money, out of the money, at the money. So it's useful for you to understand these definitions. And then a third important problem about option is the payoff. So here in the second section, we basically think about the simplest case. That is, we're just thinking about a option's payoff at the expiration date, right? So let's say if you're having a call option, and this call has the exercise price of X. And then on the expiration day, if the market price is larger than the exercise price, as a call holder, you will want to exercise the call because, again, call gives you the right to buy at the exercise price. So if market price is larger than the exercise price, then it basically means you can purchase this asset at a lower price because now exercise price is lower. So in this case, the payoff, the profit, would be given by the market price minus the exercise price. And then if the market price is smaller than exercise price, you will not exercise your call, so your payoff is just 0. And then The same kind of methodology applies to calculating the payoff to a put option. So if the market price is larger than the exercise price, you will not exercise your put because put gives you the right to sell. And if the exercise price is lower than the market price, it means if you exercise your put, you have to sell at a lower price. So you should not exercise. In this case, your payoff is just 0. And then if the market price is smaller than your exercise price, you will want to exercise your put, because in this case, you will sell at this higher exercise price and your profit is given by X minus ST. Obviously, thinking about payoffs in terms of ST and X is actually quite abstract. A better way to understand the payoff is to look at this picture, right? Look at these two pictures and see how you could calculate your payoffs and your profit for these for the buyer of the call and for the seller of the call. It's a good exercise, right? Using this exercise, you could understand these basic concepts of how to calculate payoffs. So let's now proceed to a very interesting example. It's a little bit of complicated, I would say. So you might need to take some time to carefully think about this example. So this example is about an index-linked CDS. So don't panic by just saying this weird name, right? So let me explain this to you. First, it's a CD, right? What is a CD? It's just a certificate. Oops. It's just a certificate of deposit. So essentially, it's just a deposit. Right? Now, index linked. So what is this index? It basically means market index. So if you're in the US, you could consider SP 500 as the market index. If you're in Canada, you could consider the TSX Composite Index or TSX 60 Index as the Canadian stock market index. So linked, of course, everybody knows what linked means, right? So it's market. So it's market index linked certificate of deposit. So it basically means that you're purchasing a CD, but this CD is in some way tied to the market index return. Right? So this is, in real life, you can actually see financial products like this because you will quickly see that this product has some benefit to give you a minimum return, and at the same time you can actually get some market return. Okay, so basically index linked CDs pay depositors a percentage of the equity market return while guaranteeing a minimum rate of return. So basically, if you look at a index linked CD, maybe it can say something like this. So I will guarantee 1% return. Right? So this is guaranteed. That is, no matter what happens, right, I will give you this minimum 1% return. And then I will give you, let's say, 70% market exposure. Right? Then this basically means if the stock market returns 10%, if you buy this index linked CD, you can get 7% of the market return, right? So you can see that why this is a actual financial product which has some merits, right? So basically you can see that it gives you this upside, right? And at the same time, it gives you this safety, right? Because you know that no matter what happens, you will get 1% return. So our question is, as a learner, right? As a learner of investment, how could you build a product like this, right? Just imagine you're a financial analyst, right? Or you're a CEO of a firm and you want to sell a product like this. How do you build a product like this? Okay, so the basic idea about building this index-linked CD is to use two financial instruments. The first is a bond. The second is a call. Why do you use the bond? Well, because if you buy a Canada bond, right, it's a bond issued by a Canadian government, then you know that it's very safe. So using this bond, you can guarantee the investor a minimum return. Now, why do you want to buy a call? Well, obviously you wanted to use the call by this market index, right? So basically you will buy a call option based on this market index. And then using this call option, you can actually get some market returns, right? So that's the basic idea. It's actually pretty simple. But then the question is, how could you allocate your money, right? So let's say you wanted to guarantee 1% return and you have $10,000. How much money should you put into this bond? And how much money should you put into this call option on market index? Right? So that's the real question here. Oh, I forgot to mention a definition here. If you pay attention to this, the definition of this index-linked CD, you can see that it will actually pay investors a percentage, right? A percentage of the market return. Now, what is this percentage? This percentage is called participation rate or multiplier. Right? So basically, you can see that if you look at our example here, this 70%, right, this number is the participation rate or multiplier. Okay, now let's look at the process of building a index-linked CD. Let's say you have, okay, let's first write down some notations. Let's say, okay, let me see. Oh, sorry. Let's first look at this more concrete example. Let's say at the beginning of the year, you're thinking about building an index-linked CD that never loses money at the end of the year. So basically, you have an investment horizon of 1 year, and the minimum return is 0%, right? Because you just want your index-linked CD to never lose money, right? Now let's say a 1 year T-bond has a interest rate of RF, and a 1 year at the money calls on the market index fund has a cost of $C, and the price of the index fund is S0. Now we have three questions. First, how can you design such an index-linked CD? Second, what is the multiplier of your index-linked CD? Third, assume instead of guaranteeing of never loses money, you will actually guarantee a minimum return of R minimum. How your answers to the first and the second question would change. Wow, that sounds confusing, right? So let me show you how to construct this index-linked CD. So let's first write down these three notations. So first, we know the interest rate. This 1 year interest rate is RF. So this is the 1 year interest rate. What else? Oh, we have this C. That is the price of this at the money call, right? So price of this at the money call option. And we have S0. Let me see if it's S0. So S0 is the price of the index fund. Okay. Oh, by the way, this call is a at the money call. Right? What does this imply? It basically says this call has an exercise price which is equal to S0, right? Because by definition, if a call is at the money, then its exercise price equals market price. So this call option has a strike price of S0. Right? So strike price equals S0. I am using letter X to refer to strike price or exercise price. Now, let's start building our fancy financial product which never loses you money, and at the same time you can actually get some market returns. That sounds really nice, right? So let's first think about the part the part of never losing money, right? So let's first think about the part never loses money. Oh, this is actually easy, right? Think about this. You will invest for 1 more year, and you will buy the bond to guarantee you a fixed return, right? So how much money should you put into this bond? Well, if you have, let's assume you have $1,000, right? Let's say you have $1,000. Now, you will put, okay, let me write it here. If you have $1,000, then you will allocate this fraction, 1,000 divided by 1 plus RF, into bond. Can you see why? Well, this is pretty easy, right? Because if you invested this amount into your T-bond, then after 1 year, this amount of money will become 1,000 divided by 1 plus RF times 1 plus RF. So it will become 1,000, right? So it's pretty easy to understand. So you will basically allocate this amount of money into this T-bond. Now, how much you should put into the call option? Oh, this is easy, right? It's just 1,000 minus 1,000, 1 plus RF, which is actually what? So this is, I think it's 1,000. Yeah, it's 1,000 RF. So it's 1,000 RF. So you will use this amount to buy this call option, right? So this is how you allocate your money to build this index-linked CD. So basically, we have answered the first part. Now, what is the multiplier of your index-linked CD? Let me remind you, what is the multiplier? It's really the percentage, right? So basically, if the equity market returns 10% and the index-linked CD returns 7%, then the multiplier is equal to 7% divided by 10%, which is 70%. Right? So let's see how could we calculate the, or how could we solve the second problem. So you want to find out the multiplier here. And you know that you will actually, oh, sorry, I think I made some mistake here. So you know you will put this amount of money into purchasing the call option, and the call option has a price of C, right? Has a price of C. So how many calls can you purchase? Well, this is easy, right? It's basically the amount of money divided by the price of call, right? So this gives you the number of calls you can purchase. Now let's assume, right? Let's assume the market return is R, right? So if the market index has a return of R, then this basically implies that at the beginning of the year, the price of the market index fund was S0. Then it implies after 1 year, this price of this market index fund increased from S0 plus S0 times R, right? Now, if the market index fund its price increased from S0 to S0 plus S0R, then what is the payoff from your call options? Remember, your call option is a at-the-money call option. And this call option has an exercise price of S0, right? We learned about this, right? So this basically implies that the total payoff on your call option equals the number of calls times S0R, right? So it's number of calls times the market price minus the exercise price of your call option. And we know that the exercise price of your call option is just S0, right? Because we bought at the money calls. So you can see that these two S0, they would just cancel out, right? So you could remove this, right? And how many calls do we have? Well, we know that the number of calls is given by this, right? So it's 1000 RF divided by 1 plus RF times C, right? So essentially you can see that this portion is number of calls and this portion is payoff of, this portion is the profit or payoff of a single call option. Oh gosh. Let me, okay. So you will actually earn this amount, right? Now, what is the return on your index-linked CD? Well, if after 1 year, your index-linked fund has earned this amount, then you would just use the profit divided by your initial investment, $1,000, right? So this would give you, so this would give you, oh boy, you know what? My Apple Pen is acting weirdly. Right, so you will have this. So this is the return on your index-linked CD. Now, what is the definition of the multiplier? It's really the return on your indexed liquidity divided by the market return. And what is the market return here? So market return here is given by R, right? So the multiplier is given by okay, this is okay, what happened. Is given by this guy divided by R. So again, you can see that you could actually cancel out 2 R's. So multiplier is given by this guy. Okay. Oh. This is really bad. Sorry for that. So, so basically you can see that the lecture note gives you the answer here, which is multiplier is given by RF times the initial price of the market index fund divided by call price plus call price times the risk-free rate. I also you can see that the process is sort of like proving this, right? So in the exam, if there's a exam like this, you're only required to know how to use this formula. This proof, so this step is not required. That is, I will not ask you to prove, to show how could you get this multiplier. But these 2 parts are required because these 2 parts basically talks about how much money should you spend on the bond and how much money should you spend on the call option. Now let's look at the third question here. Assume instead of assume instead of the guarantee of never loses money, you want to maintain a minimum return of R mean. So you can see that the guarantee of never loses money is actually a special case. It basically says that I'm guarantee you that the minimum return of this index linked CD is 0%, right? That's what never loses money means. However, now let's say you want a better return. Maybe you want to guarantee a 1% return. In this case, how your answers to this to the above 2 questions would change, right? That is, how much money should you put into your bond? And how much money should you put into this call option if you want a minimum return of R mean here? Well, this is actually pretty simple, right? So you can see that if you wanted a return of R mean, then what you wanted to put is, so I will just directly give you the answer here. So you will allocate this amount to bond. That is, let's say if you have $1,000, right? So if you allocate this amount into the bond at the beginning of the year, then after 1 year, this amount would become this, right? So basically you can see that again, these 2 guys would just cancel out, and then this $1,000 would become 1,000 plus 1, 1,000 times 1 plus R mean. And you can see that this is just your guaranteed return, right? And of course, if you wanted to allocate, this amount into your bond, then obviously you should allocate 1000 minus 1000, 1 plus R mean divided by 1 plus RF. You would apply or allocate this amount into your call option, right? So you will allocate this amount into call option. And then you would basically repeat this step here, and you will find out the multiplier is given by this formula, right? Okay, again, let me reiterate what is the requirement on this index-linked CD. The first, you need to understand how do you find out the allocation of your money, right? How much money should you allocate into bond versus how much money should you allocate into this call option? That's the first question you should understand. The second is, how do you calculate the multiplier? Again, you will not be asked to prove how to solve this multiplier. The requirement is you need to understand how to plug in numbers to solve this multiplier. Okay, great. Now let's move on to the third section, which is about the put-call parity for options. Put-call parity is actually a very basic and a very important theorem in option theory. So I plan to spend not several lectures. I plan to spend maybe 20 minutes on this. It's basic because in the future, I mean, if you learn a more advanced class on options, then you can see that this put-call parity could give you a lot of interesting result. So let's now just start. Okay, so to talk about this put-call parity, let's first think about two different ways of making investment. The first is using call plus bond. The second is using put plus a equity. Okay, so let's look at the first. Let's look at the first way of making your investment. It's call plus bond, right? So let's say you will buy a call with exercise price X, right? So this is your first portfolio. You will have a call and it will have an exercise price of X. And then you will have a bond, right? And this bond is a zero coupon bond. And it has a face value of X. And we further assume the call and the bond, they have the same maturity. Right? That is, on the same date, the call would expire and the bond would just mature. Right? Now, the second type of strategy is put plus stock. Right? So you would buy a stock. So here, you will buy a stock. And then you will buy a put option. So here you will also have a put option, right? And then this put option will have an exercise price of X, right? And then the put option will have the same maturity as the bond and as the call option. Right? So that's the requirement. That's how you build these two portfolios. Now, what's so special about these two different investment strategies? Well, the interesting thing is, if you look at these two portfolios, right? This first guy and this second guy. These two guys, they will give you the same payoff, right? That's the interesting part. And then from our knowledge on this present value, we know that if two things, they give you the same future payoffs, then their price today should be the same, right? So that's basically the law of one price, or the no arbitrage condition. You should have learned about this in, I think it's in your corporate finance 1 class. So, okay, let me repeat. So the story here is we built two different portfolios based on two different ways of investing, right? So the first is a call plus bond, and the second is a put plus stock. And later you will see that these two different strategies have the same future payoffs. And by the law of one price, if these two strategies have the same future payoffs, then we should have the same prices today, right? So that's the basic story here. Now, to facilitate our discussion on this put call parity, so let's lay down some notations, right? So let's say the call option price today is C, and the risk-free rate is RF. The stock price is S0, and the put price is P, right? So basically you can see that the call has a price of C, the bond has the interest rate of RF, the stock has a today's price of S0, and the put has a price of P. Now, the first step to understand put call parity is to understand why these two different investment strategies give you the same payoffs, right? So let's look at this table. And these two tables will tell you that, these two different strategies indeed give you the same payoff. So let's assume on the expiration day, the price of this stock is ST, right? So this ST is basically the stock price on the expiration date. Now let's first examine the payoff on the expiration date for this call plus bond portfolio. So let's say the first case, right? So the first case is the stock price is smaller than exercise price. Well, you guys should have known this, right? If stock price is lower than the exercise price for a call option, then the call option holder will not exercise this call, and this call will just expire worthless. So the value of the call would be just 0. And then the value of the bond, of course, it's just X. Remember, we have bought a bond with a face value of X, right? So X in this example refers to both the exercise price and the face value. So we assume this bond is riskless. Basically, it means that on this maturity date, you will for sure get X dollars, the face value, right? So the value of the zero coupon bond is just X. Okay, now let's look at the other case. If price is larger than exercise price, then this is good news for the call option holder, right? This call option holder will want to exercise the call and buy this stock at a price of X. So the payoff of the call option would be the market price minus exercise price. So that's why you get ST minus X here. And then the value of the bond is still X, right? Now, what is the total value of your call plus bond portfolio? Well, you can see that this column gives you the total value under the assumption market price is smaller than the exercise price. So you can see that it's X. And for the other case, it's ST. Now let's look at the second investment portfolio, which is put plus stock. So in this case, if market price is smaller than the exercise price, well, luckily you have this ST here because, hey, we're talking about stock. It's always ST, right? ST here. Then the only difference is about the value of this put option. So if stock price is smaller than the exercise price, as a put option holder, you will want to exercise your put because you can sell this stock at the exercise price, which is higher than the market price. Now your profit is basically given by X minus market price. Right? So this is your payoff. And in the other case, if the market price is larger than your exercise price, you will not want to exercise your put option. So the payoff here is just 0. Now this is the interesting part. The interesting part is if market price is smaller than X, the total payoff for this put plus stock investment strategy is X. And if ST is larger than X, the total payoff is just ST, right? So the nice thing here, the important thing here is this and this. This versus this, right? You can see that under two different scenarios, the call plus bound strategy has the same payoff as the put plus stock strategy, right? Now, what's the implication of this? The implication of this is if call and bound have the same future payoffs as the put and stock portfolio, then these two kinds of investment strategies should have the same present value, right? So this is exactly put comparative theorem, right? So you can see that this formula basically says the present value of the call plus bound equals the present value of the stock plus the put option, right? Because you can see that what is C here? C is today's call price, right? What is this guy? This is essentially the present value of the bound, right? Because the bound has a face value or par value of X, and it's risk-free. So we should discount this par value using the risk-free rate, and we have T periods. So this is the present value of the bound. What is X? It's today's stock price, right? What is P? It's today's put option price. So you can see that the put call parity theorem is actually pretty easy to understand, right? You just construct two different portfolios, right? Put plus stock and call plus bound. And then you would see that, hey, these two different portfolios have the same payoffs, so they should have the same present value, right? You can see that I have repeated this like several times because this theorem is really like the foundational result in option evaluation theory. It's really basic and important. Okay, very good. We could also write this put call parity into a simpler form, right? So this thing is just present value of the of X. So this is equivalent to say C plus present value of X plus, equals S0 plus P, which gives you P equals C plus PVX minus S0. Or you could say C equals P plus S0 minus PVX, right? Okay. Now let's see a very interesting result of let's see a very interesting problem, right, about the put call parity. So you might wonder, hey, what happens if there is a violation of this put call parity theorem? So now let's see this example here and see, first let's see whether these numbers, right, whether these numbers violate the put call parity theorem. Second, let's see what can you do if there is a violation. Well, we are thinking about, well, we're in an investment class, right? So ultimately, thinking about investment is about making money, right? So you will see that if there is a violation of put call parity, then you can actually earn some arbitrage profit from such a violation. Okay, so okay, let's look at these numbers. So first, we have a stock price which is 110, and next we have a call price. So this call has a 1 year expiration and its strike price is 105 and its price is 17. And we have a put. It has a 1 year expiration. The exercise price is 105 and its price is $5. And next we have this risk-free investment, right? And then the interest rate on this risk-free investment is 5%. So now let's first answer the question whether the put call parity is violated. Okay, so to check whether this is violated is quite simple, right? Because you could just plug in numbers into this put call parity and see whether this parity actually holds or not. Remember that put call parity says C plus PVX equals P plus S0, right? What is C here? Well, it's just $17. What is PVX? It's the present value of X. So it's 105 divided by 1 plus interest rate, which is 5%. What is P? Well, it's just 5, right? What is S0? It's 110. So now let's see what kind of numbers do we have here. So in this left-hand side, we would have 17 plus 10, which is 27. Sorry, it's not 27. It's actually 117. So here we're having 115, right? So obviously you can see that the left-hand side is strictly larger than the right-hand side. So basically put call parity is violated, right? So this is the answer. So this is the answer to the question A, which is yes, it is violated. Now, let's look at B here. How can you profit from such a violation? Well, generally in finance, if a certain law is violated, you can generally make arbitrage profit, at least theoretically. So in this case, how could you earn this theoretical arbitrage profit? If you have some experience, you would know how to do such a arbitrage. Generally, you can see that. So you can see that the left-hand side is actually larger than the right-hand side, right? So basically, it means that you will short sell the left-hand side and you will take a long position in the right-hand side, right? Because the underlying assumption is if this put call parity is violated and you find out the left-hand side is more valuable, it basically implies that the left-hand side is overvalued and the right-hand side is undervalued. So you will want to take a short position in the overvalued side, and you will want to take a long position in the undervalued side, right? So that's why you want to short sell. Okay, maybe let me write it here. So you will actually short sell left-hand side, right? And you will take a long position in this right-hand side. Of course, you can see that this is bad English because you cannot short sell left-hand side. What I'm really trying to say is you should short sell the assets on the left-hand side, right? So you will short sell a call, and you will short sell this bond, and you will take a long position in this stock and in this put option. And then you can find out short sell call option and short sell bond. These are really awkward languages, right? So they sound really awkward. So short sell call basically means you will sell a call option, right? So you should sell a call, right? What does short sell bond mean here? Well, short sell bond short sell bond basically means you should borrow money, right? Because buy a bond basically means you're taking a long position in the bond, right? And then what's the opposite side of buying a bond? Right? It's borrowing money, right? Because buying a bond essentially means you're lending out your money. So the opposite side of purchasing a bond is borrowing money. So what you would do is you will sell a call option and you will borrow money, right? Now let's see the answer and see how you could exactly do this arbitrage. As I said, you will buy stock and you will buy put. So you can see that to buy the stock, you will spend $110. To buy the put, you will spend $5. And then you will sell a call. So you will earn $17. And then you will borrow money. How much should you borrow? You should borrow the present value of this $105. And the present value of $105 is just $100. So you will borrow $100. And you can see that after borrowing, you will get $100 of this positive cash flow. So what is your total cash flow? It's just $2. That is, you will get your $2 arbitrage profit, right? Which is pretty easy to understand because you can see that if you short sell, you will earn $117. And if you buy, you will have to spend $115. So your profit is the difference between these two numbers. That is $2. And then you can see that this is arbitrage because no matter what happens in the future, you will just get zero here, right? So the gain and the loss in the future will just offset with each other. I will let you figure out these numbers, right? Just consider this as a mini exercise, right? To find out why do you get zero under these two cases. It's worth mentioning that this put call parity is a special case. This put call parity here is obtained by assuming there is no dividend, right? But what's the more general case when there is dividend? Without proving it, I will show you that if there is dividend, then the put call parity will be like this. So you can see that If you assume d equals 0, you will get our original formula. You will get p equals c minus s0 plus pvx. Okay, so this is the simplified case we just discussed about when we assumed no dividend. Okay, another comment is this formula. This put called parity is only applied to European options. For American options, the put call parity is given by this. In this class, you're not required to know the put call parity on American options. You're only required to understand the put call parity on European call options. And let me remind you what's the difference between European call and a American call. So if you're having a European call option, then you can only exercise your call on the expiration date. And a American call option gives you higher flexibility, right? You can basically exercise your call anytime before or on the expiration date. So that's the difference here. Okay, now let's move on to the fourth section, which discusses about the general rules on option values. So now let's first start from the simple part. Some very simple definitions. So a option's value can be decomposed into two parts. The first part is called intrinsic value. The second part is called time value. What is the intrinsic value? It's the profit you can get if you immediately exercise your option. So how do you calculate your option's intrinsic value? Well, if it's a call option, then depending on whether it's in the money or out of the money. If it's out of the money, then it has no intrinsic value. It's just a zero. And if it's in the money, then the intrinsic value is given by the market price minus the exercise price. For put, the definition is similar. If it's out of the money, then its intrinsic value is just a zero. And if it is in the money, then its intrinsic value is exercise price minus stock price. The second part is called time value. Time value is defined as option value minus intrinsic value. Now, why this term is called time value? Well, it basically means value from time, right? So why time has value here? In the case of option, time value is essentially volatility value. It's about possibility. Think about this. If you have a call option, and this call option now is out of the money, which means the intrinsic value of this call option is just a zero. But why the out of the money call option still has a positive price, right? Well, it's because it has time value. Why this out of money call option has time value? It's because in the future, as time goes, possibly, right, the market will move in my favor. So possibly the out of the money call option will become in the money. And then my in the money call option will become valuable to me, right? So it's about possibility. If you wait, as time goes, the market could move in a favorable direction, right? So you could benefit. That's why you have time value here. And you can, based on this argument, you can actually see that if your option is very close to its expiration date, you can imagine that its time value will be very, very small, right? Obviously, because if you're very close to this expiration date, then the possibility, right, the future possibility is very little. So there is very little time value left. Okay, let me see what this picture is about. So basically this picture gives you, several curves, right? You can see that first this blue curve. Blue curve is about the value of the call. Now what about this line? This guy here. Well, this line is essentially intrinsic value, right? Why this gives you the intrinsic value? You can see it here. If stock price is larger than the exercise price, then the call will be in the money. So if you exercise the call immediately, then you will get this intrinsic value, which is exactly S minus X, right? And on the left hand side, if stock price is smaller than the exercise price, you will not exercise the call, and in this case the intrinsic value is just a 0. So you can see that this line, right, basically, so this line gives you the intrinsic value, and you could also see that the difference between the blue curve and the yellow line gives you the time value, because we know that time value is the difference between option value and intrinsic value. Okay, that was quite abstract, a bunch of definitions. So let's see, how do you actually calculate intrinsic value and time value? And you will quickly see that it's really simple. So basically now you can see that we are having this Apple stock here, right? The first number gives you the Apple stock price. So it's $123.42. You can ignore these green numbers, right? 6.45 tells you the price now minus yesterday's close price, and 5.51% tells you the percentage change of price compared with yesterday's close price. But we will not use these numbers here. We will just care about stock price. Now what about this guy? Well, this is a call option, right? Maybe I could talk about the notation here. So this is a call option based on Apple stock, right? AAPL is basically the ticker symbol for Apple stock. November 2020 is the expiration date. And you would wonder, why there is no date? Well, because by convention, the third Friday of each month is the option's expiration date. So basically, the exact expiration date for this call would be the third Friday, November 2020. Right? So date is removed. And what is this? Well, this guy obviously is the exercise price, right? And this tells you it's a call option. And the call option has a value of $5.23. Now you can see that we have this guy here, the third guy. It's a different call, right? You can see that it has the same expiration date. The only difference is it has a lower exercise price at $121.25, and it has a higher price. Now let's look at the first call. This guy here. The first thing you need to know that the first thing you need to know here is this first call is a OTM call. It's out of the money. Why it is out of the money? Well, because its strike price is 1 to 6 and stock price is 1 to 3.42. So you can see that because exercise price is larger than the market price. So this is a out of the money call. And in this case, the option value, well, it's quite obvious. You could just read from this picture here, right? It's 5.23. Now, what about its intrinsic value? It's out of the money. So its intrinsic value is 0, right? So it's 0. Now, what about the time value? Well, it's simple because time value is the difference between option value and intrinsic value, right? You can see that it's $5.23, right? From this example, you can see that time value could actually be quite large, right? Think about this. It's a out of the money call, and it will expire in November. It's not a very distant time, but still, it's worth $5.23. Okay, now let's look at the second call, which is a ITM call. It's in the money, right? Again, this means it's in the money. Why it is in the money? Because its exercise price is 1 to 1.250, which is smaller compared with this stock's market price, right? So it's in the money. And in this case, if it's in the money, it should have a positive intrinsic value. In this case, you would use stock price minus exercise price. So option value is pretty easy again, right? It's just basically 7.6 reading from the picture. And intrinsic value is given by the difference. So it's 2.17. What is time value? Again, it's the difference, right? So it's 7.2 minus 2.13. So we get a time value of 5.34, right? So you can see that for this call, the time value is still quite large compared with its intrinsic value, right? Okay, now let's talk about the second topic, right? Second topic about general rules on option values. So now we want to think how the value of call and put will be affected by different variables, different determinants. Right? So let's first look at American calls and American puts. Because most of the time when when textbooks are discussing determinants of option values, they will just talk about American calls and American puts. Now, think about this. If you have a call, right? If this market price of this stock increases, how the value of your call should change? It should increase, right? Why? Now think about this. If you have a call, its intrinsic value is given by what? It's given by market price minus strike price. If you have a put, its intrinsic value is given by exercise price minus the market price, right? Now think about this. If stock price increases, then you can see that the intrinsic value of the of a American call option will be higher. So this basically tells you that this American call option should be more valuable, right? So its price should increase, right? So that's why you get a plus sign here. The American put would be on the opposite, right? You can see this from the intrinsic value. If market price is lower, if the market price is higher, now you can see that the intrinsic value of your American put option is lower. So in this case, the American put should be less valuable. So you should have a negative sign here, right? Now think about the second variable, the exercise price or the strike price, right? Again, you can see this from the intrinsic value argument. If strike price is higher, call's intrinsic value will be lower, so call will become cheaper. What about put? If strike price is higher, then intrinsic value of the put will be higher. So put should be more valuable. So you should have a plus sign here. Okay, great. Let's look at the third guy here. Time to expiration. You can see that for both call and put, if you have longer time to expiration, both call and put will be more valuable. What's the argument behind this? Well, it's because, put it simply, it's because if you have longer time to expiration, then time value will be higher. So call and put will be more valuable, right? Now, why time value is higher if you have longer time to expiration? Well, because we said the time value is essentially about possibilities. It's the volatility value. So if you have more time, if you have longer time, then it's more possible this market will move favorably, and it's more possible you will get a higher return, right, if the time is longer. So that's why given longer time to expiration, call and put should be more valuable. Now, there's a second reason. At least in terms of calls. Now, if there is a longer time to expiration, then think about your payoff from a call, right? If you're holding a call, your payoff is given by the market price minus exercise price. So if you have longer time to expiration, then the present value of your exercise price will be lower, right? This essentially means your payoff or the present value of your payoff will be higher.